Before we get into production example, let's look at conceptually how the hair system works in XSI. We'll just look at the hair from surface example to basically look at the conceptual view of hair. So we have our polygon selected. We can do a hair from selection. Now basically a few things are happening there. If we look at the hair object, it actually got created and was placed as a child of the source mesh. And underneath the hair object, we have a hair generator operator. And on that operator, we can actually set the sub-D level of the hair. So if your underlying mesh is a sub-D level of 2, you can match the hair so it actually fits on the surface of your mesh. Very useful, especially for organic characters. You don't want a gap between the hair and the actual body of the object. If we look in the kinematics area, we can see a couple things are happening here. The local transform of the hair is muted, and a pose constraint is set up to actually constrain the hair object to the mesh. And this basically allows the hair to follow the object as it's translated around. And also, if we look at the actual hair object, basically what we get is we get one hair guide placed per vertice. So the more dense your mesh is, the more hair guides you're going to have to manage and control. So it's something really to keep in mind when you're working with hair. So if we look at the overview, basically when we apply hair, the hair guides get created, and it's these guides we style and edit to basically sculpt the shape of the hair we want. From there, if dynamics is applied on the hair, the dynamic simulation will involve the hair guides only, and this is basically for performance reasons. After the hair is simulated and cached to disk, we're basically ready to build the render hairs. Basically, the render hairs end up interpolating from the guide hairs. So all the render hairs in between the guide hairs will interpolate based on distance from the guides. When the render hairs are generated, additional effects are basically applied to these render hairs. So, for example, the kink and frizz, splay, all these settings are basically applied to the render hairs once they're generated. So once we have the final render hairs, we're ready to actually shade them. So we offer two options for rendering hair, a volume solution and a geometry solution. And basically the same hair renderer works in both modes. If we go on the actual hair primitive, from here we can actually select whether we're going to use a volume shading approach for rendering or geometry. In 4.0, there's actually a new hair geometry shader we provide. So there's basically two options if you want to render using geometry mode, and one for volume. And basically these shaders are passed through mental ray and are used to render the hair out. So that's a brief conceptual overview of how the hair system works in XSI.